This lecture will help you to gain more familiarity with the F-test. In this lecture, I am going to brief about F-test and assumptions, and I will solve a problem on F-test also. So F-test is a parametric test. I have solved many parametric tests and those videos are available in my YouTube channel. You can search in the playlist of my channel. So let us go into the F-test. So what is F-test? Where basically, very simply one word you have to keep in your mind when we are testing a hypothesis. When we are testing a hypothesis about equality of two population variance, we have to use F-test. So we have to check the equality of population variance between two population variance. Then we have to go for F-test, which means to test variance only we use F-test. So you may know that before applying to t-test, while we are testing a difference between two population means in t-test, one of the main requirement is to check that equality of variance of two population. When we are applying to test difference of two population mean in t-test, but this assumption can be checked with the help of F-test for two population variance. So which means to check two population variance we use F-test, which is a very important statistical tools in many contexts. For example, an economist may want to test whether the variability in income differs in two population, say district A and district B. So in such cases we can go for F-test. We may have one more example. A quality controller may want to test whether the quality of a product is changing over time. Even in such cases also we may go for F-test. So in many contexts F-test will be applied. So which means since F-test is based on ratio of two variances, it is also known as variance ratio test or F-test. In F-test, we basically concentrate on two population variance, that is why which can be called as variance ratio test. So let us go for who developed this F-test. So F-test is named by George W. Snedecor in honor of its developer Sir Ronald A. Fisher. So Fisher developed this F-test. Fisher has worked a greatest milestone in statistics. So F-test is also developed by Fisher, but this F-test, the name F-test is named by George W. Snedecor. So this F-test, some author use this test as a homoscedastic test because two population with equal variance are called homoscedastic, which means this homoscedastic word derived from two words, that is homo. Homo means same and sadistic means variability. Since we concentrate mostly in F-test on variability, so this can be some author called this as a homoscedastic test also. So let us let us look into the some assumption of a F-test. So as all assumptions of parametric test will apply here also. So firstly, the population from which the samples are drawn must be normally distributed, which is a basic assumption which must be met by any population that we are going to consider into our study. So which is a basic assumption of parametric test also. And the samples must be independent of each other. Say for example, brand A and brand B. So these are independent population. We don't have to consider here one the independent variable and one more dependent variable. So both the variable must be independent only. So this is about assumption. These are the formula we may use to solve the F-test statistics. Firstly, this is a formula. F is equal to variance 1 divided by variance 2, which means variance, since we consider only here variance, we go for variance. So variance of population 1 and divided by variance of population 2. So to find out variance of population 1 and population 2, we may use this formula. So if you are given directly variance of sample variance, you can consider it into the formula directly. Otherwise you need to calculate sample variance from the given sample. In such case, you have to follow this formula. That formula is sample variance is equal to 1 by n1 minus 1. Since we have two population in F test, so the n1 is a first population thing, and x is also first population thing, and summation of x minus x bar whole square. So by doing this stuff, we can obtain sample variance, or also we can use this formula in place of this. In the computational simplicity, we can use this formula, that is 1 by n1 minus 1 into summation x square minus summation x whole square divided by n1. So the same formula for sample variance of population 2 also. So here sample variance of 1, here sample variance of 2. Here population 1 we have considered, here we are going to consider sample 2, and here x we have considered, here we will consider y. Y means one more sample. Okay, the same in the same place we can use this also for the sake of computational simplicity. So either in any one of the formula we can use and find the sample variance. So now let us look into the simple problem. I will solve a simple problem in this video. So here two sources of raw materials are under consideration by a bulk manufacturing company. Two sources of raw material. Both sources seem to have a similar characteristics, but the company is not sure about their respective uniformity. So some bulk manufacturing company considering two sources of raw material, about that given data are given about that. So a sample of 12 lots from source A yield a variance of 125. So firstly we have one population, that is a sample of 12 lots from a source A yield a variance of 125. So since they have given directly variance in that too, which is a sample variance, that is sample variance is this sample variance, so which is not a population variance. So this symbol we can take into a population variance. This symbol we can consider as sample variance of yield A, source A, and sample of 10 lots from source B yield a variance of 112. So we are having two data of source A and source B. So is it likely that variance of source A is source A significantly differs to the variance of source B at significance level 5% 1% alpha, which means they are asking source A do you think source A significantly differs to the variance of source B at 1% alpha? We have to check this by formulating a hypothesis, and we have to give our decision. So here I have extracted some of the information from this problem, that n1 that is source A, number of sample in source A is n1, that is 12, and variance of n1, that is a source A variance is 125, source B sample is 10, source B variance is 112, and alpha is 1%. So these are the extracted information from this. So based on this, now let us formulate a hypothesis, and then we can move to give a solution over this. So for formulating a hypothesis, we have to concentrate on this sentence, that is it likely that variance of source A is significantly differs to the source of variance of source B, which means we have to our claim is, so it differs, which means that our claim is variance source A differs to variance of source B. Here yeah, what for source A and source B I have denoted with the population standard deviation, population variance 1, population variance 2. Since we are dealing in F test, we are dealing about variability, so we have considered variance. So if variance 1 and variance 2 denote the variance in the raw materials of source A and B respectively, So our claim is variance 1 differs to variance B, which means they are asking, is it likely that variance of source A significantly differs? So for that, differs means we are assuming our claim is differs means source A variance to source B variance differs. So our complement is source A variance does not differ to source B variance. So which means variance 1 equals to variance 2. Since our complement contain equality sign, we will take complement as null hypothesis and remainder claim as alternative hypothesis. So what is our null hypothesis then? Variance of source A do not differ significantly to the variance of source B. And our alternative hypothesis is variance of source A do not, sorry. So source A differs significantly to the variance of source B. So here source A differs to source B. Here source A do not differs to source B. So this is our null and alternative hypothesis. Since alternative hypothesis contain equality sign, our test is a two-tiled test. In parametric test, one-tiled, two-tiled is very important just to take a decision. So one-tile, two-tile is very simple. Two-tile means rejection region falls in both side of the region. So we have to reject from both side. If it is one-tile, rejection region falls in one tile of the region. So since to decide whether it is two-tiled, one-tiled, we have to concentrate on alternative hypothesis. Our alternative hypothesis is a two-tiled. So the test statistics is a two-tiled. So now let us go for applying our test statistics. So these are the extracted information I have already extracted from the problem. So this is our formula. So what is the formula? F is equal to S1, S1 means sample variance of population 1 divided by sample variance of population 2. So directly sample variance is given in the problem. We don't have to find out this sample variance using some other formula. So we can directly apply to the formula. So when we applied that variance of source A is 125, variance of source B is 112. So our F test statistics would be 1.11. So test statistics in this case is 1.11. So after testing statistics, we have to obtain critical value. In this video, I am not covering step-by-step approach to solve F-test because all parametric testers follow the same steps to give a solution, so that procedure for testing a hypothesis is enough. So no need to make a separate video again and again for each and every test. So after finding a test statistics, now let us go for obtaining a critical value. So for obtaining critical value, so how to obtain critical value? Since as I told you, which is a two-tiled test, so critical value of test statistics for two-tiled test at 5% level of significance. So it must be 5% level of significance. Even in the problem also I have shown you 1% level of significance there, which is a 5% level of significance. For that we have to make a ready our data. Since we have two population, we have to make ready our degree of freedom. So corresponding 5% level of significance. So F is n1 minus 1, which means n1 is a sample of 1 and n2 minus 1, so which means sample second which will be subtracted for the sake of degree of freedom. And since it is two-tiled test, we will divide our alpha, that is a significance level, by 2 because rejection region has to falls from the both side of the region. So I will apply this to the formula. So n1 is 12 minus 1, n2 is 10. Here n2 is 10 minus 1. Since our alpha is 0.05, that alpha is 0.05 by 2. So here 12 minus 1 will be 11, 10 minus 1 will be 9, and 0.05 divided by 2 will be 0.025. So we have to see F distribution or F table or the table which we used to see for ANOVA. We have to see that F table. So F table for degree of freedom 11 for V1 and 9 for V2. We have to see in the F table for 0.025 level of significance. We had a 5% level of significance. Since we have divided by alpha by 2, our new level of significance is 0.025. Then let us go for the table. So I will show you the table. You can download this table from the Google. So this is a table for a degree for looking a degree of freedom. So you may see here, firstly there are different tables. Firstly I will let you know how to read this table. My level of significance is 0.025. My level of significance was 5%. I have divided alpha by 2, so my level of significance is 0.025. So here in the V1, this row is V1, this column is V2. This is a F table, V1 V2. Our V1 is N1 and V2 is N2. So our V1 N1 is 11 degree of freedom because 12 minus 1 11, and V2 9 degree of freedom because 10 minus 1 9. So for 11 for at V1 11, V2 9, for 0.025 alpha we have to see. So which means this is our interested area. So this is 11 degree of freedom, 11 degree of freedom, and here 9 in the V2, 9 in the V2. This is V2, V2 means N2. This is V1, V1 means N1. So in the row we have N1, in the column we have N2. So our table value for this the particular degree of freedom at 0.025 alpha is 3.91. Now we have to compare our tested value with our critical value. Then we may come to a conclusion. Now last stage to make a decision about null hypothesis. So our tested value is 1.11 and our critical value, tabulated value is 3.91. And I think you may know that how to make a decision under parametric test statistics. Since it is a two-tailed test, the rejection reason falls in the both side of the reason. So I have generated critical reason for the F test. You may see in this table. So here red shaded area are rejection reason, and these are rejection reason, and non-shaded area is non-rejection reason. So our tested value is 1.11. Imagine this is mu is 0, and our tested value falls here somewhere 1.11, and on the left side falls here somewhere 1.11, but our critical value is 3.91. To the right side here it is 3.91, and to the left side here it is 3.91, which is clear that our tested value is lying in the non-rejection region, whereas a shaded area is rejection region and non-shaded area is non-rejection region. So since our tested area falling in the non-rejection region, we do not reject a null hypothesis and we reject our alternative hypothesis, which means we are rejecting our claim at 5% level of significance, and we conclude that samples variance of source A do not significantly differ to the samples variance of B. So let us see what was our claim and what was our complement, null and alternative hypothesis. See here, this is our claim. So what is our claim? Claim is variance of population 1 equals to variance not equals to variance of population 2, which is our claim. Since we are rejecting alternative hypothesis, we are rejecting our claim and we are accepting our null hypothesis, which means variance of source A do not differ significantly to the variance of source B. So this is about our decision about null hypothesis, and this is my referred material for preparing this video. Thank you so much for watching. Please stay tuned for my next video. In that video, I will solve one more problem on Ftest where I will also solve how to calculate sample variance for population 1 and population 2 also. So thank you so much for watching. Please do subscribe to my Vision Academy YouTube channel.